I'll let Robert tell you a little bit about himself and about Tangible as he starts this talk, but we are incredibly excited to have him join us here this morning. He's a speaker, he's a trainer, he's an author, man of many things. So Robert, why don't we go ahead? I'm going to go ahead and turn the slide off. So last chance to grab Twitter handles if you're looking at the slide, and then we'll hand the baton over to Robert to get started. Sound good?
That sounds great. And thank you for remembering the Twitter handle. It's like the last thing on earth I ever think of. So that's great.
I'm always in fear of getting it wrong because, you know, one typo is you kind of screw it all up. But no.
Right, inundating somebody who isn't me.
Exactly. So, okay, so we're going to go ahead and stop sharing so you can start sharing.
Cool. So hello, everyone. I'm Robert Hoekman. I'm going to stay on video here for just a second before I start screen sharing. I'm on an iPad, so once I switch over to screen sharing, my video disappears, but I wanted to say hello and show you this rad room behind me. It's a fake room. It's actually a real room in my house. I just happen to not be in it at this moment. The actual room behind me is a closet door, so be glad I'm showing you the nicer place. My dog might be making an appearance. He's decided to be suddenly very whiny. At any rate, I'm Robert Hoekman. I had the pleasure of working with Jim and Alex recently on some stuff at CNN Politics, and that's how we got connected. And so I'm here to talk about rapid experiments, a habit of rapid experimentation, and in particular, a tool that we use at Tangible to codify how rapid experiments get done with teams. We actually spend a lot of time working with teams and mostly in enterprise clients, injecting rapid experimentation as a part of their product development process. But Jim is absolutely right. In the past 21 years, I think now, in my web experience, I wrote a few books along the way, wrote a bunch of articles. Most notably, books-wise, I wrote Designing the Obvious back in 2006, and then 2010, I think, was the second edition. I also did a book once with Jared Spool called Web Anatomy, which is about interaction design frameworks. And a few years ago, most recently, I did a book called Experience Required, which is about how to become a UX leader regardless of your role. Cool. So great. So I'm going to start screen sharing actually now, assuming that all works. I think it should. Jim, you let me know if everything's good.
You got it.
Excellent.
Yep.
Cool. Right, so I'm actually going to leave this in exactly the state that it is so that I can see what slide comes next. So we're going to talk about rapid experiments, Kata-fied. And that's a little play on words, obviously, the word codified. We're trying to implement some rigor and some practice into the idea of rapid experimentation. And the word kata is part of that. And I'm actually going to talk about what that means in a minute. But here I am. Again, I'm Robert. I work with Tangible. This is what I do in my personal time. Every so often I get to go for a joyride on some sort of motorcycle. This picture was taken by a professional photographer during a Yamaha test ride. That was pretty awesome. And the reason I'm showing you this picture is because I actually want to build up a little bit of credibility and likability before I tell you a very uncomfortable truth. And in a room full of UX professionals, so the uncomfortable truth is going to be particularly uncomfortable. So we're starting out with a bang. Here's the uncomfortable truth, but it's a good thing, I swear. It's uncomfortable, but it's good. Here's the truth. Design is prediction. Deployment is reality. And by that, I mean that when we design things, we often are making, actually invariably, are making a whole bunch of assumptions. We are assuming, even if we've got really, really great research feeding into our decisions, we are still assuming that we know exactly how to solve the problems that were identified in the research. And once we, yep. See, there's my dog trying to eat stuff. Cool. And once we start making assumptions, we also start assuming that we know the best way to solve those problems. And what happens is that even if we've got all the greatest research, all the greatest designers, even if we've vetted our designs, what happens is when we go to put something out into the world, we start finding out that something was different than we expected. The first thing that happens, it's happened to me 150 times. The first thing that happens, you put something out and users start interpreting it differently than you thought they would. It turns out there was some critical piece of information missing. Basically, what you find out is that you have to deploy something to find out how well your prediction actually held up. And so this is why I say design is prediction, deployment is reality. It's an uncomfortable truth, but it's incredibly pragmatic. And the sooner we all embrace it, I think the better, because it gives us the opportunity to pivot our thinking and start thinking about how we can prove stuff. Oh, here we go. Okay, so fortunately, there's a very delightful solution to this. Yay. And the delightful solution is this idea of rapid experimentation. And rapid experiment is literally what it says. It's scientific inquiry. It's the scientific method applied to product development. So a rapid experiment is really rigorously a hypothesis and a minimum viable test designed to apply the least effort to gain the most evidence. Now, there's a couple of big ideas in this. First is that, yes, our design should actually be hypothesis driven. And the minimum viable test means that, how about instead of spending a huge gargantuan effort to put something out there based on a hypothesis, we spend as little effort as humanly possible to find out if our idea is correct and give it some evidence before we start advancing it, before we start investing in it. And really the benefit there is that we don't overinvest in ideas until we've proven them out a little bit. And actually, as we do that, we can end up delivering value as we're proving out ideas. We can put something out into the world that gets part of the way there, part of the way toward our business objective or user objective. And then we can continue building on that. So of course, here's an illustration I'm sure many of you have seen before. This gets batted around in conversations. And by conversations, I really mean debates about minimum viable products. It's this idea that, instead of designing a whole car and then incrementally building the car, starting with the wheels, the chassis, maybe the steering column, all that stuff, until eventually you get to a car, never realizing any value at all until you build the complete object and get it out into the world. Instead of doing that, with rapid experiments, what we aim to do is find out what we actually need to achieve to satisfy a business objective. Whatever our objective is, would 4 wheels and a board cut it? Maybe, if not, well, what did we learn from 4 wheels and a board? Well, we learned that people have balance problems. So let's add a bar to it, turn it into a scooter. Or maybe now they want to go faster. Whatever that is. I often refer to minimum viable test rather than minimum viable product, because it's not always a product you're building. It may be a service, it may be a business process internally that you're trying to solve, a very human oriented or human conducted process. It's not always a design problem. It's not always a product problem. And so I refer to a minimum viable test. But basically, if we start by defining a business objective, clearly defining, quantifying what it is we're trying to achieve, then rapid experimentation is about figuring out what is the least we need to do to try to achieve that business objective. And so that's what rapid experimentation is really about. So here, so this happens. This happened for real. I run rapid experiments with teams all of the time. Tangible works with several enterprise clients. I work with a bunch of teams inside of these clients. And basically we instill this practice of rapid experimentation along with several other ideas that go along with it. But just a kind of quick case study example here. So a rapid experiment, I was working with an enterprise team who was in charge of a fraud platform. Basically all of the transactions that went in and out of the company, they were approved or not approved by machine learning, essentially, but the machine basically spat out yes, no, or maybe. The maybes went to a team of humans who had to look over a transaction and decide if it might be fraudulent or not. And all of that was to make the machine learning platform smarter. Now, these specialists, there are about 1,000 of them inside this enterprise, and they spend, hours. This is their whole job. All they do is they look at these little transactions, and they work these cases all day, every day, and they decide whether these transactions were fraudulent or not. And when they do that, they actually conduct a huge number of kind of frivolous or non-productive steps while they're doing it. So there's a lot of copying and pasting. There's a lot of moving back and forth between tabs to sort of corroborate information about a person, about the transaction, the person who performed the transaction. They write a lot of case notes. They do all sorts of things. So in studying that, we were looking at that and saying, well, the ideal scenario here for the fraud platform is that we would increase the amount of cases that could be worked year over year without adding more staff. Basically, make the whole program more efficient. And so to do that, we looked at these little micro actions that these agents were taking, these specialists were taking. And we conducted an experiment where, actually several experiments, but one in particular, we decided, well, if we could automate the way that they took case notes, could that make them more productive? So as part of this case notes thing, they had to upload screenshots of the images, or excuse me, of the information that they corroborated during an investigation. And so we looked at that and went, wow, there's about 9 steps involved in that. What if we could cut that down by supporting image pasting so that they never had to save an image, never had to delete it from their computer because they're not allowed to save personal information, things like that. What if we could reduce the number of steps involved in that? We tried that, and it took about 4.5 days total to build that particular experiment out. It took about 4.5 hours to design the thing, put it into a click-through prototype and validate it with users. And then it took about 4 days to actually build it and run it through UAT and deploy it. So about 4.5 days total. That was all the effort involved. And when it was deployed, we ran a test. We used a control group and a test group, and we kind of compared their data over, their performance stats over a few weeks. And what happened was the test group actually performed on average between 10 and 25% better per specialist per day across the board. So the people who were using this new streamlined task flow were able to work 25% more cases per day, which is insane. Which year over year would actually save, I think it mapped out to like a 15% year over year productivity increase for the entire program. And that was basically with one little tiny experiment that we ran. We said, what if we can make this process more efficient? Let's design this little tiny thing that took us 5 days, put it out and see what it does. And that's what it did. It had this huge, huge effect. And I have tons of stories like this. In fact, I was telling a different one earlier today. But this is one great example of how a rapid experiment can actually take a little micro action, a little micro solution, and actually have a really big business effect on the other end of it. Now, experimentation, I think, actually should be our default way of thinking. A lot of product decisions, a lot of product development happens based on someone's opinion or someone's insight or someone's, we're looking at heuristics, basically. We hear a customer complain about something, or we hear a few people complain about something, and we think there's a real problem there. But what rapid experimentation posits is the idea that we should actually break down those current conditions, those target conditions, form a hypothesis, and then use data and real evidence to find out whether there actually is a problem there and whether we can solve it, whether we've got the right solution for it. So it should actually be our default mode of operation. It should be our kata. And there's that word again. So rapid experiments, kata-fied. Kata is a Japanese word that means routine or way of doing things. It's actually, I'm sort of adapting it from lean manufacturing, but kata is pretty common in Japanese culture as a whole. If you've ever taken martial arts or played taiko or something like that, Jim will know what what taiko is. But kata is your form. It's your way of practicing. And I think experimentation should be our routine. It should be our way of doing things. And all of this is actually just in context of something that we at Tangible call value-centered innovation. Instead of focusing strictly on users, strictly on technology, or strictly on the business, we actually focus on all three of those things and pull those three minds together and form an objective. We often do this inside of a workshop, but then we devise a bunch of potential experiments to run, and we prioritize them, and then we go about conducting a bunch of rapid experiments to figure out which ones are good, which ones get us closer to that business objective. And if they're good, we iterate on them. If they're bad, we pivot away from them. But we keep it lean. We keep doing these rapid experiments so we can find out which ideas move forward and which ones don't. So here's the stuff that I think you really, so now that you've got some context around rapid experiments, here's the stuff that we want to talk about. It's the nuts and bolts of what a rapid experiment actually looks like. So going into that, I'm going to show you, I'm going to give it a little bit of context before I give you an example here. So let's say that your value proposition, and this actually came from a class that the founder of Tangible and I just finished. Let's say that your value proposition is a wait time tracking app. So it's the time of COVID, right? Everybody wants to go to stores safely, but what they don't want to do is go there and wait 2 hours to get into it. They don't want to show up and find out there's a long line. So let's say that you've got a value proposition of putting together a time tracking app so that customers who want to shop in stores can go and know what to expect before they get there. And let's say one of the features you've identified is this, the core elements of this solution is an appointment scheduling option. So you've decided, as part of this, you could actually enable people to set an appointment to go to the store. So now there's not going to be any line at all. So I've adapted this from something that they did. They actually went off in a different direction than I did, but I took this and kind of ran with it because I wanted to build an experiment out of it. So let's say you've got this idea for an appointment scheduling option in this service. So based on that idea, I went, okay, what would a rapid experiment look like if we wanted to test out appointment scheduling for a brick and mortar store? So I pulled out the rapid experiment canvas, and that's what you're looking at now. The rapid experiment canvas is just this. It's just this simple. It's 2 rows, 5 boxes in each row. The top row is basically the heart of it. The second row is mostly the logistics, the planning, and then the outcome of the rapid experiment. And I'm going to go through each of these boxes and talk about sort of the ins and outs of each one of these. But this is the whole thing. And later on, if you're interested in this, I have a template for this that I will be happy to send you if you contact me, and I'll give you that information at the end here. But this is it. This is a rapid experiment canvas. So up top, you give it a name. You say, what the date was, you give it a little summary. In fact, it was Jim's idea to add the summary of the rapid experiment canvas. I did a little work with Jim and Alex recently. Yeah, I never had a summary in the rapid experiment canvas until Jim said that. So it was a great idea. And I stole it and ran with it. So, but we're gonna go through each one of these. It's just these 2 rows. So the first thing in the upper left is the current conditions. Now, current conditions, all of this is imaginary. That's the word I'm looking for. So pretend that this is a real experiment. I have run dozens and dozens and dozens of experiments just like this, but I made this one up for the sake of not breaching anyone's NDA. So the current conditions, let's say 20 to 30 people a day are calling a store to find out what their current wait times are, their hours, their availability, things like that. At off-peak times, there's maybe a 10-minute wait. At peak times, there's maybe a 2-hour wait if people are just walking up. There's no appointment option currently. Once somebody actually gets into the store, it takes them maybe 20 minutes to do their thing, to get what they need and check out. But all of this negative experience, this unpredictability is actually driving up complaints about this. So the store staff is fielding complaints every day, 5 or 8 of them, and they're getting negative Yelp reviews as well. Those are the current conditions. The important thing to call out here is that not only is this a list of facts about what is currently true that we're going to try to improve, but if you note, each one of these is quantified. We've actually put a number behind it because numbers are the absolute best way to measure our progress, whether we've actually had the effect that we want to have with our design decisions. So we've quantified all of these things. We've got 20 or 30 calls a day, several complaints, several Yelp reviews, negative Yelp reviews every week. So we actually put all of that together. And the way that we know what the current conditions look like is by putting together it's basically a journey map, but we tend to do really, really robust, detailed versions of them called a value stream diagram. Where basically we diagram the entire sequence of steps that people go through now in order to solve a problem for themselves, in order to earn the thing of value that they are after. So in this case, we diagrammed out that whole process. What are people doing? And we came up with that list of current conditions. Now the target conditions come directly out of that set of current conditions. Well, if the current conditions are that they get a bunch of calls, 20 or 30 calls per day, let's get that number down. So the target should be, maybe we get fewer than 10 calls a day. Maybe the wait time at all times of day is fewer than 5 minutes, because that would create a really great experience for customers, and that would ensure that they'll come back more frequently. We won't be deterring them with this terrible wait time. So let's say 80% of customers in this target state world are appointments instead of walk-ins. That's what will enable us to get to that 5-minute wait time, right? People can show up, check in, say, I'm here. It's very much like a Genius Bar idea, like the Apple Genius Bar. You set an appointment, you go, you talk to a concierge, check in, and your wait time is very short. And as a result of that, we're able to get, down to diminish the number of complaints that happen per day, and ideally stave off the negative Yelp reviews every week. So these are the target conditions. They come directly out of that set of current conditions. Now the next box is obstacles. What are the things that are preventing us right now from achieving that set of target conditions? In this case, and that really is that simple of a question. What is standing in our way right now? What is preventing us from achieving that set of target conditions? In this case, the obstacles are that there is no, convenient ability to book appointments for this store's customers. We would need to create some broad and consistent customer awareness of this option. We would need to have some sort of operational plan for what happens when people show up. We need to check them in. We need to manage them when they show up and make sure that the wait times are always up to date, things like that, make sure we're staying on schedule. And we would, can ideally take some proactive steps to prevent negative reviews. Those previous steps, customer awareness of this appointment option should help that. But maybe we could also do something at the store itself to raise awareness of this. So now we know that the current conditions, the target conditions, and the obstacles. Now these 3 boxes are kind of the core of your experiment, because these define, you can actually spawn multiple experiments based on just that information. So how many potential solutions can you come up with based on those current and target conditions in that list of obstacles? Well, you can run multiple experiments based on those same 3 pieces of information. In this case, I went to form a hypothesis based on one particular idea, which was this appointment booking option. Now I'm going to talk a little bit in more depth about how a hypothesis works in this case, but as you can see here, the hypothesis for this feature is if customers can easily book a shopping appointment, then at least 80% of customers who use that scheduler will prefer it over walk-up shopping. Now, there's a couple things happening in this hypothesis. If you notice that the if clause, and I'm going to point that out here. So first, a hypothesis should be an if-then statement. The second point is that the if clause benefits the user. So in this case, if customers can easily book a shopping appointment, that is something that we're offering to the user. The then clause will benefit the business. So going back to the hypothesis, you'll see at least 80% of customers will use the scheduler will prefer it over walk-up shopping. That would be a benefit to the store, because that means we're now getting a whole bunch of people who are scheduling appointments and not just showing up, which means we can manage our inflow of customers. We can keep everybody on schedule. Our routine becomes very predictable during the day. We're getting fewer complaints. This is our theory. Like, all of that stuff will get a lot better if most people are preferring the scheduler over walk-up shopping. Now, the next point about the hypothesis is that the business benefit must be measurable. This is incredibly important. This is an absolute essential point for hypotheses, is that they must be measurable. If you can't measure it, in fact, I'm going to jump to that slide. If you can't measure it, you can't improve it, says Peter Drucker. So we want to make sure that the hypothesis is in fact measurable. So we're saying at least 80% of customers who we show this scheduling option to will prefer it. And if they do that, then we'll get the result that we want. Basically, all of those things, we'll get that much closer to all of those target conditions that we described. Now, the last point about a good hypothesis is that it should describe a specific change with a specific result. This is really important too. So don't use ambiguous language in your hypothesis. Don't say things like more or better or what have you. We're saying at least 80% of customers. So here's our specific change. If they can easily book a shopping appointment, there's a specific change, because that is not currently true, and we're going to introduce that ability. So we're defining a specific change and a specific result, and that is that most people who use the appointment booking tool will prefer it over walk-up shopping, and now we'll start to achieve our effects. So that is a specific chunk of language, and that's really important to have in your hypothesis as well. The clearer, the better your hypothesis, the better you can run your test. Now, a quick note about hypotheses. There are kind of a couple of different kinds. In some cases, you have benchmark data, and in some cases, you don't. And if you notice in this hypothesis, I said 80% of people will prefer it over walk-up shopping. So right there, this tells you this is a comparative hypothesis. We are improving on the baseline. So we've got benchmark data, and we want to improve on that benchmark data. Now, in cases where you don't have that, you've got an aspirational hypothesis, which basically means you are establishing the baseline. This might be a brand new company you're launching, a brand new product, and you want, right out of the gate, you want a 10% conversion rate within 15 days of your launch. You have no benchmark data at the moment, but you're going after it, and this is a good aspirational goal. You know from market research that a 10% conversion rate is pretty solid. You think that's achievable, so that's your aspirational goal. So in our case, we have a comparative hypothesis. We believe that people will prefer it over the existing method. So those are important notes about how to write a good hypothesis. And just for fun, and I can share this deck with you guys later, but just for fun, quick show of, if anybody wants to chat at Jim and just form an opinion here, which of these two is a good hypothesis? Example one, if we improve the usability of case notes that are entered by support agents, then the agents will be more productive. Example two, if specialists use a template instead of a free-form text input, then case handling time will reduce by 20% and cases worked per day will increase by 35%. Feel free to jump in the chat and let Jim know which one of those examples you think is a good hypothesis.
I'm getting a barrage of twos. One person says one.
One person says one. Okay, well, I'm going to go with the barrage of twos because it's very specific. So this if clause describes a benefit to the user. The then clause describes a benefit to the business. It's a specific change. We're using a template. Using a template instead of a free-form text input, and the hypothesis is measurable. So 20% reduction in case handling time and a 35% increase of cases worked per day. So the correct answer is 2. There's a benefit for the user, it's specific, there's a benefit for the business, and it's measurable. It hits all of the rules for a good hypothesis. Now, skipping back over the Peter Drucker quote, let's talk about the minimum viable test. This is the last box in that first row. So the minimum viable test, this is a little bit tricky as well, because this hypothesis is a measurable statement, right? So now your job is to figure out how you can measure that hypothesis without doing anything more than what you have to do. So in this idea, in this instance, our hypothesis is, we'll introduce this shopping appointment scheduler, and 80% of people will prefer it, right? So our minimum viable test is we need some way to schedule appointments. We need to compare it to people who are doing walk-up shopping. We need to track whether they prefer one over the other. So there's several things happening in our hypothesis here. We need to be able to measure whether somebody prefers one over the other. So there are several things in this hypothesis that are basically telling us what our minimum viable test needs to do. So we talked it over with a group, and we decided, with our team, and we decided, well, let's post a link to Instagram, and let's have a survey about the walk-up experience. And let's have a smartphone-friendly appointment scheduling page. So we'll put up this page where people can schedule an appointment, and then we'll put up an Instagram post saying, hey, we're running this experiment. We'd love your feedback. Try this out, let us know how it goes. And then we'll include a survey there to rate the prototype experience. So now we have a way to compare the walk-up experience to the appointment scheduling. And we have a way to get that out to our audience without actually building anything. We're just standing up like this fake page, basically, and facilitating schedules or appointment scheduling. So the minimum viable test is, whatever you need to build to test that hypothesis. Don't do anything more than that. Stop there. If you're doing more than that, then you are over-investing in an idea that you don't yet have evidence for. So the second row is much, much easier. The second row is logistics. Some of it is logistics. So this first box is participants. This is just a list of who on your team is going to do what when you put together the experiment. So project management will be handled by someone. Someone will do, design and put together a prototype, a PDF prototype. Someone will handle marketing. So that Instagram post, that will be someone. And someone else will write the survey content. So now you've got, everybody has their job to do. They can whip up that experiment really easily. And then also the people who will participate in the experiment. So in this case, for our sake, this will be Instagram followers for this company. We'll enlist people through Instagram. So that's all that happens in the participants box. Just a list of who will be involved in constructing the test and who will participate in it. Next is the schedule. This will be a start and end time. Now, the start and end can also be a condition. It may not be a time. Maybe our test is ready at opening, at store opening time on Friday, February 26th at 9 a.m. And maybe we just run it for that day. Or maybe our test ending conditions are, we've gotten 1,000 responses from this. So that's when we'll stop. If that took a day, then great. If it takes 3 days, who cares? Maybe it's a condition. Once you meet a certain number of test participants, that's when you end the test. But regardless, you just want to plug in the schedule for your test so you can decide when you're going to start it, when you're going to end it. That's it. The next bit here is measurement methods. And the reason this is important is because the point of a rapid experiment is to learn from it. So in order for us to learn from the experiment, we need to track metrics. And that's where this measurement methods box comes into play. So in our case, all of this stuff is going to come directly from the hypothesis. The hypothesis was, how does the walk-up experience rate? How does the prototype rate? Who prefers which one? Things like that. So here are some things that we can measure out of that test. We can measure we can have people rate their convenience on a scale of 1 to 5. How convenient was it to schedule an appointment or to walk up? How confident were you that you'd be able to get into the store? through both of those options? How long was your wait time? How likely are you to visit the store again within the next couple of weeks or next time you have a need for a product that the store sells? And finally, what is your preference? These are all questions you can ask about both situations, both the walk-up situation and the appointment scheduling situation. So you can take this survey in either case, and now you can compare them. And so what you're going to do is as part of your test, you're going to figure out how you're going to track these things. And in this case, it's going to be a survey that people will take after walking up and shopping that way, or after using the appointment scheduler. Now, that is important because we now need to gather the results that came from the experiment. So let's say, we've run the test, we've gotten a bunch of people who participated in it, and the average ratings, we've collected it for the walk-up experience and the appointment scheduling experience, and we've decided this is what came out of it. So on a convenience scale, it was only a 2 on a scale of 1 to 5 for the walk-up experience, but the prototype, the appointment scheduling, that got a 5. Confidence that you'll get into the store, that was a 1 and a 4 respectively. All of these things came out of it. And it turns out 95% of the people who participated in the test preferred the appointment scheduling option. Now, this is good intel. Now, you haven't yet really built anything. All you've done is like post a link to Instagram, you've made a little survey, and you've put up like a very simple rudimentary scheduling page. You haven't really invested in anything yet. Maybe you even did this through Calendly, and you just had appointments. Maybe you used an outside service and made it really simple. You didn't even build anything. Well, now as a result of this test, you have certifiable data that you have a good idea. 95% of your participants preferred the new solution. So now okay, this is a really good idea, and now we should implement this idea. We should build this, we should offer it, we should make it permanent, we should scale it. This is good intel that shows you have a good idea, you're going in the right direction, and you should keep going. That leads me to the results plan. And I'm going to be done here in like just a couple minutes, but so that leads me to the results plan. The results plan is what you're going to do based on the information that you learned from your experiment. So you've got all this great data from your experiment. What are you going to do based on that information? So let's say the next step is, well, let's implement a Wizard of Oz type solution. So that way we can start offering this appointment scheduler now, even though we haven't built it yet. We'll have someone at our store whose job it is to handle these the schedule management while we're building out the real solution. Maybe we put up an actual web page where people can plug in their preferred times, and then someone at the store handles that, and we post regular Instagram reminders of this new option. And maybe at the storefront, we actually even throw up a QR code in the window and say, hey, scan this QR code and you can choose your appointment time. And that starts to increase awareness as well for the people who do walk up. So that is the entire thing. That's the whole, where did it go? That's the whole rapid experiment canvas, just those 2 rows, but it's what's true now, what's true later, what should be true later, what's standing in the way, what do we believe we can do, and what effect will that have? What's our hypothesis? And then organizing that minimum viable test, and then just going through the logistics. Who's going to construct the test? Who's doing what? When do we start it? When do we end it? How are we going to measure the effects of the test? What data came out of the test, and what are we going to do with that information? And that's the entire rapid experiment canvas. Now, some things that happened on the way to this Zoom call. I was just telling Jim before this started that James Young, the founder of Tangible, and I just finished teaching a course on design thinking and rapid experimentation for Stanford Continuing Studies. And Our last class was actually just 2 nights ago, where everybody in our class, we had 8 teams, there were 40 people, and we had 8 teams, and they all had gone through this. They constructed experiments, they did market research, they did all sorts of stuff, came up with value propositions, they ran experiments to find out if they were good ideas, and then they put together decks that pitched their ideas to us basically and said, here's the problem in the market, here's how we went about solving it, and here's our evidence that it's a good thing. Now, that class was on Monday night, and here are some really rad things that happened during that class. So we sat back and watched 8 teams tell us about what came out of their experiences. This particular team put up a landing page and got a 20% conversion rate for their thing. And I just want to give this some context. They learned about experiments a week, on one Monday night. It was 3 Mondays ago. The following Monday is when they had already finished the experiment and had to report out the results to us. So in 1 week, this team put up a landing page, drew traffic to that page, pitched their product and got a 20% conversion rate and put together this data and presented it to us in 1 week. And this is rock solid good information to tell them that they have a viable business idea that they could actually chase after. Another team got a 35% increase in satisfaction. They were doing kind of an A/B test with an existing problem and then their solution of solving that in a new way, rather. Satisfaction went up. They got a 7.5% sign up rate. They also did this test in a week. Now, here's the fun part. Not everything always goes well. And in this case, there was a team who had this really cool landing page. They did a great job. They even bought their own domain. They did some really good stuff. It was high-end design. Like, it was fantastic. They had a way for people to sign up. They only got a 1% conversion rate. And there were a couple of factors that they think were contributing to that. But basically what they learned from this is that their idea, as they framed it and as they put it together, did not work. So instead of having, over-invested in an idea they just thought was good and they thought was a right idea and they thought had legs, they actually proved to themselves with very little effort that they did not have it right yet. And they needed to go back to the drawing board and tweak their hypothesis a little bit and try something else. Something about their test was wrong, something about their hypothesis didn't pan out. Maybe it was their business idea. Whatever it was, they only got a 1% conversion rate. So they're going to go back to the drawing board. This actually stopped them from doing something really bad. If this was in a business, if this was in a team, this would stop you from advancing an idea that would turn out to be really bad for you. So you can every bit as much learn from an experiment what not to do as what to do. So all of that said, all of these students, all of these teams put together their experiments in a week and just learned fantastic things in a very, very short period of time. So if you think you could do that, and I absolutely hope that you can, that you do think you can do that, I would like to offer you a template for doing this. So I've shown you the rapid experiment canvas, and I have a PDF version of this that has an example. It's actually this example, and then a second page in the PDF that is a blank version of this template. Now, you can just as easily go off and just draw your own, but the example could be really helpful. And there are a little bit of there's some annotations in the template and stuff that give it a little bit more context. And just having that example there can help you really tighten up and get good answers as you complete it, as you start to learn it. There is a bit of a learning curve putting this thing together, but by the second or third try, you start to go through defining a rapid experiment. You start to get the hang of it. So if you want to get this template, by all means, please contact me. We'll make sure that everyone has this information. And what I want to do now, so I'm Robert Hoekman, and I'm at Tangible. You can just Google, Tangible UX, and you'll find me through that way. You can use the contact form there. You can use this email address, whatever you want to do, and I will send you this this template. So with that said, that is everything I have to say about rapid experiments. and I want to open up the room for questions. And I'll actually stop screen sharing here in a minute, just so that I can be on video when you guys are talking.
Right. Excellent. So we have some questions. In fact, I'm going to go ahead and if I can figure out how to do this with Zoom, I am going to go ahead if folks want to start their video, and I'm just going to kind of open the room up, and let's go up through the chat here and see what questions we have. We have some really good ones. I'm just going to go to the beginning and work my way down. So let's see. First question is, here we go. Carl Kaufman asks, did you investigate for programmer bias in the setup of the machine learning, which probably skewed the results? This is the fraud example early on.
Wow. Right off the bat with a huge tech question.
Yeah.
Unfortunately, the machine learning part was well outside of my purview in this case. So there was a team of data scientists who were behind the algorithms that went into the machine learning platform. And I actually was not touching what they were doing. What my job was to deal with the app that the specialists were using. So when the maybes came out of the system, this might be fraudulent, it went to this team of humans, and that was the app that we worked at. So I wish I could answer that question, but the data science part, well out of my territory.
Got it. Thank you. Great presentation.
Thank you.
Diana asks, what if you have limited resources of participants due to occupation and job responsibility specifications? How would you only test minimal features as opposed to a fully fleshed out list of user needs per user testing session?
I want to make sure that I understand that question again. Would you mind reading that again?
Sure. So what if you have a limited resources of participants? I think the question is, you just don't, for whatever reason, don't have a lot of participants to work with. How do you only test minimal features as opposed to everything that you would like to test? I think that's the gist of the question.
Okay, so that's interesting. So there's kind of two different kinds of tests, sort of two big buckets of tests, and you can look up all sorts of design tests. In fact, there's a book out there somewhere that has like 100 and something of them, which is really super useful. But I kind of group them into these two buckets, which are indoor tests and outdoor tests. And indoor tests are anything that happens pre-deployment. So you've got, click-through prototypes, validation sessions, you've got friendly users either inside the company, maybe friendly users that you have a good relationship with outside of the company. If you're in a B2B situation, maybe you've got certain business customers who are good allies and are really invested. Those are your candidates for indoor tests. If you've only got a few of them, that's fine. Make sure that they're good subject matter experts though. They're good representative people who have a lot of knowledge, but are also really, as invested as your actual customers might be. And then there's an outdoor test. The outdoor test is where things like A/B tests might fall, or Wizard of Oz tests or something like that, or even smoke tests where you put up a landing page and see if you can get conversions. An outdoor test is anything that you can actually deploy and put out into the world. Because there's going to be, again, design is prediction, deployment is reality. So there's going to be a big difference between what people say or might say or respond to in a click-through prototype in a validation session. There's going to be a big difference in how they respond in the real world, right? Once a feature is live, they're not sitting in a Zoom call talking to you. They're actually living their lives and doing things differently and under those pressures and those distractions. So you get very different sort of results there, right? So if you put out an outdoor test, you can release that to a very small segment of your audience. Again, if you've got, in a B2B situation, you might have business customers that are loyal. You can release a feature to just them. The best way to kind of use both of those is to use an indoor test to inform a design and then an outdoor test to evaluate a design. So you can use that indoor test to make sure that you've understood the problem correctly and that you have a good idea. You can use it to get evidence that your idea is a good one before you go and build it. Now pivot, let's say you get good intel out of that, good data, good results back from that. then you pivot to your outdoor test and start to scale it. So now you're starting to build that actual solution out. You're leaving click-through prototype land and going into real code. So now you're starting to build things and release it to either your whole audience or to a segment of your audience. So in either of those cases, you can have very, very limited user bases for your tests. But in either of those cases, you should try to make sure, particularly with the indoor test, you should try to make sure that there are people who know a lot about that subject area or are really invested in your solution. And with the outdoor test, you can release it to a very small percentage of your audience. And you can actually treat it the same way. There might be a certain segment of people who would really care about that stuff, and you try to target them that way. I hope that I'm interpreting that question correctly. If I'm not, please feel free to bug Jim again through the chat, and we'll see if we can follow that up.
So Devin asks, how do you know, this is a great question, how do you know which problems to go after? Is it the amount of customer or member complaints?
I could give a whole other talk just on that.
I know where this answer is going.
Right. So Jim knows where this is going. So yeah, it's a fantastic question, and it's actually the next inevitable question that you should ask after thinking about rapid experiments. In fact, I was just working with a team recently who was sort of neck deep in acting on a strategy, and they just wanted help quantifying like the results of their design work, right? And so we started with the rapid experiment canvas with them, and then they started going, is our design actually achieving what we set out to design? And if so, how do we know which designs to work on in the first place? They asked that exact question. It was the very next step in logic. The answer to that is through some serious prioritization exercises. So basically, at the outset of a project, if a strategy is not yet defined, what we do at Tangible is we actually run a pretty immersive strategy workshop with teams where we take a look at everything that is true now. So out of the landscape of stuff that you're trying to solve, what is the current truth? And we diagram all of that out. And then we look for problems in that current. So the current conditions box in the rapid experiment canvas, that's like a micro problem. But in the strategy workshop, we do it for the macro problem. We'll start by diagramming out the current process somebody goes through to, let's say, buy health insurance, or to, let's say in CNN politics, to get the latest poll results on election night. There's a big macro problem there, and we diagram out that whole problem, how people solve that. We identify problems in it, and then identify or brainstorm potential solutions to those problems. And then through a couple of exercises, we prioritize those. We decide which of those potential solutions might have the biggest impact, might have the biggest or least level of effort, might have the most or least risk involved in putting it together. We basically organize those solutions according to certain criteria, and we come out of those with a bucket of things that we should work on now because they're really important, and they must go forward immediately. And then the stuff that we can wait on. So we come out with 3 buckets. It's now, next, and later. So there's the now bucket. That's the stuff that you prioritize. That's the stuff that made it through that sequence and is the most important stuff to work on first. So then you pluck the things out of the now bucket, and those are the things you experiment on first. Now I could absolutely, I would be happy to come back and talk about what that strategy workshop looks like. But yeah, there's basically you have to look at the whole landscape and prioritize which thing to come first. And I would love to talk more about what those prioritization exercises look like.
So it really starts with like strategy, and then you kind of prioritize from there.
Yeah, that's absolutely right. Yeah, it starts with strategy. So yeah, the prioritization is kind of a result of that strategic thinking. A lot of times, and this is such a funny thing, and let me know if you've seen this, but a lot of times projects, again, are born like out of someone's idea. Like, I think there's a market opportunity here. Let's go do it. And like, next thing you know, your team is spending 6 months on something that may be vapor. And so you don't want to do that. So everything we do is all, see, you're nodding and smiling. Yeah, we've all seen it. So we try to inject sort of critical thinking back into that process and go, well, how do we know? Well, let's actually look at the current reality. Let's diagram out the current reality and find out what problems are really there, and then see how people are trying to solve them now. So through that strategy, we find out which problems are most important, which problems might actually help our business the most by helping our customers the most, which problems are just kind of minor or could be solved by some disruptive startup down the street. Which ones are really important to us, could really help us, could really help our customers. Those are the things that become the most critical. And I would love to go through what all of those exercises look like, but that's basically the gist is, yeah, like start thinking about that whole process, and that will give you a prioritized list of solutions. And then those are the ones that you start working through them in order as you go through rapid experiments.
Okay, thank you.
Great question, thank you.
Let's do one more question. I'm going to combine two because they're kind of related to each other.
Sure.
I'm going to do Stephen's and Lynn's questions. So Stephen asks, how do you determine the metric goal? Why 80% and not 70 or 95%? And Lynn asks, then how do you determine if you have enough data to give an accurate measurement to assess the hypothesis? They're kind of related to what does success look like, and how do we choose where to have that line?
Yeah, honestly, the throttle for the answer to that is usually circumstance. So like in the hypothesis example from tonight, the 80% goal was something that would sufficiently free up staff time and sufficiently make them competitive with other businesses who were already handling appointment scheduling, right? So that answer might be informed by outside circumstances. It might be like, well, what do we need to achieve in order for us to be in a better position so that we can keep going? I worked with a company a few years ago. This is actually one of my favorite go-to stories, where they needed to get product trials. It was taking them 9 days to spin up product trials in this big B2B enterprise cloud computing situation. But there were all these startups out in the world that were doing it in 1 day. 1 day. So they were 8 days longer just to spin up a product trial than the startups were. So in order for this company to become competitive, they had to cut 8 days off of their product trial spin-up time. That became our hypothesis, was, we believe if we do this, so that was our goal. We had to get it down to under 1 day. So sometimes that's informed by outside circumstances. And in other cases, it might be informed by, it might be aspirational. Again, like we know that 10% market-wide of a conversion rate is pretty good. So let's aim for 10%. Let's try to hit that. If you don't hit it, maybe you get 8 or 9%, that might be okay. But if you're getting closer, if you're only hitting 1% and your goal was 10, then you're probably way off. So it might be informed by your competitors, it might be informed by the marketplace, it might be informed by the ROI for your staff. What would make it viable? What would make this solution viable for you to get a good return on your investment is really where that comes from. And then the number of participants in the test. If you're doing an indoor test and all you have is like a click-through prototype and some user validation sessions, then you'll need, at least a few people. The general rule is like 5 to 8 people will give you decent feedback. Obviously not hugely quantitative, but really you're trying to inform your design at that point. If you're going outdoor, I would give it a good chunk of your audience. If you have very low traffic, I would, just shoot it out to all of your whole market. If you're CNN and you have 4 jillion users every month, like you could release something to 0.5% of your audience for a day and probably get a ton of data back from that. So in that case, you're looking for something that's quantitatively significant, which would probably be at least 1,000. Generally agreed on at least 1,000, but in an indoor test, qualitative setting, I'd say probably 5 to 8. If you can't get that many, it's all about the quality of the people that you get. Maybe you only have 3 subject matter experts, but they're really great. That's fine.
Excellent. These were fantastic questions. Thank you, everybody. Thank you, Robert. This was a great talk. I'm definitely getting some questions like, hey, can he come back and talk some more about the second part of that? So we might be hitting you up. Tonight's talk yeah, tonight's talk will be is being recorded. It will post it on YouTube in our NovaUX Meetup YouTube channel. So search for NovaUX Meetup, all one word. And Robert has graciously agreed, keep me honest here, to share some version of these slides, and as well as the PDF of that template too. So please definitely reach out to him if you're interested in those. Next month's meetup, as I said, is on April 14th. Frank Olasky is going to be talking about accessibility of data visualization. So we haven't done a whole lot of talks on either data visualization or accessibility. So this is going to be a really interesting one. He's done a bunch of workshops online and for several organizations. Good guys. So we're looking forward to that talk. So if you sign up on Meetup, remember, don't forget to tell your friends to also register for the Zoom details, so they get this meeting information so they can join the meeting. If you are interested, or someone you know is interested in giving a talk, organizing a panel discussion, giving a workshop, or something else that would be fun and interesting, please reach out. We'd love to hear from you. And if you have ideas of a talk or something that you think you would like to see that would be really interesting, happy to take suggestions for those as well. You can reach any one of us. We're all on social media or through the Meetup site. We would love to hear from you. So, Robert, thanks again. Thank you so much for joining us this evening.
Thank you.
Jody, yeah, excellent. Jody, thank you for covering social media for us. And we will see you all very soon. Thank you for joining us this evening.
Cool. Thank you, guys. Hi, Emily.
Hey, Emily.
Good to see you.
Good to see everybody. Thanks for joining us.
Thanks, guys.
Happy Patrick's Day.